Hi everyone, welcome to your lesson on Law of Conservation of Matter, or it's also referred to as the Law of Conservation of Mass, and you can also sometimes see it referred to as the Law of Conservation of Atoms. They all mean the same thing. So, before we get into writing anything down on your graphic organizer, I want to just show you a picture to get you understanding what you're going to be looking for with the law of conservation. So when you have the word conservation, to conserve something, the word conserve means to save. So basically to save matter or mass. And we're not actually saving, but you'll see what it means in just a second. So what do you see? We have a balance, and I want you to answer the question, what is its purpose? For the balance. Why did I pick this picture with both pan A and pan B being exactly the same? So when the pans are both at the same height, what does that mean if you have masses on both pans? So if I were to take a hunk of atoms and put them in pan A and a hunk of atoms and put that in pan B, what would this scale tell you about the masses of both of those pans? Well, it would tell you that they were equal. So we're going to keep this in mind as we continue on through this lesson. So the law of conservation of matter. The actual law itself states that matter or mass cannot be created or destroyed. It can, however, be rearranged. In a chemical reaction, the mass of the reactants must equal the mass of the products. And in just a minute, you'll see what reactants are and what products are. Oh, what is that? So, thinking of the balance that we started off the lesson with, everything must be equal. Whenever there's a chemical reaction, the part that goes into the chemical reaction is going to be equal to the part that comes out. So when matter goes through a physical or a chemical change, the amount or the mass of the substances that you begin with must equal the amount or the mass of the substances that you end with. And what that means is that matter was conserved. Nothing was created out of nothing or destroyed. You can't take matter and turn it into nothing, and you can't take nothing and turn it into matter. So the before and after must balance out. Why, you ask? Well, the law of conservation of matter or mass is a law. It is the same every single time that matter or mass is measured before and after a chemical reaction. Again, matter cannot be created or destroyed. So, let's get to the reactants and the products. The reactants are the left side of the chemical equation. They're the atoms on the left side that are reacting. So they are before the chemical reaction has taken place. The product is the right side. They're after the chemical reaction's taken place. So reactants are the elements or compounds that react in a chemical reaction, and the products are the result of the reaction. Technically, the two sides should have the same mass. So, in order to figure out if the two sides have the same mass, we have to learn how to count atoms. So, how can you count atoms, and what if the mass isn't the same? First, we're going to deal with counting atoms. So, to count atoms in a chemical equation, you must use math. Whoa! Once again, science and math overlap. Okay, so equation 1. We are first going to look at a reaction between hydrogen and oxygen. And this reaction between hydrogen and oxygen is going to create water, H2O. So before we start looking at and dissecting the little numbers and the letters, we need to figure out what they're called. So the little numbers are called subscripts. They're kind of like exponents because they're little, but they're on the bottom instead of up on the top. And one way I like to remember that is sub, the B in sub, bottom, and also submarine. Submarines go down towards the bottom. And subscripts tell you how many of a certain element there are. So if we look up at the H, there's a subscript of 2 that tells you that there are 2 hydrogen atoms reacting with 2 oxygen atoms, and then that arrow is called a yield sign. The yield sign is said as hydrogen plus oxygen yields H2O. Remember, a single element has only one capital letter, whereas a compound has more than one. So we know that the H and the O on the reactant side, they are not a compound because they're separated by a plus sign. It's a 2 atoms of hydrogen plus 2 atoms of oxygen yields H2O. That is a compound. Now, if we had chlorine in this mix, it would be capital C, lowercase l. Capital C, lowercase l. And if we had capital C, capital L, that would not be chlorine. That would be something totally different. Okay, counting atoms. How many hydrogen atoms, again, are there on the reactant side? Remember, the reactant side, that's the side that's reacting. So that's the left side. 2 of each. How many on the product side? 2 hydrogen and 1 oxygen. Okay, so counting atoms. More practice. What's different about this one? So equation 2, there's something different. There are big numbers. These guys are called coefficients, and you distribute them just like in math. And so what that means is you multiply them. So looking at the reactant side, we can see that there are 2 nitrogen. Okay, that's just like the last one. You look at the subscript. And there are, for hydrogen, it says 3. The big red 3 is the coefficient, and then H, and then 2. So what you're distributing is the 3 to the 2. So 3 times 2 is 6. So there are actually 6 hydrogen atoms reacting with 2 nitrogen atoms. And that yields 2NH3. And if you distribute the 2 to the N, you notice that there's not any subscripts written next to the N. What that means is that there's 1. And we don't write the subscript 1, just like in math, we don't write the number 1 many times whenever it's next to a letter. We don't do that in science either because math is the language of science. So we follow all the rules for math that when we use them in science. So 2 times 1 is 2, so there's 2 N's on the product side. And then 2 times 3 is 6, so there's 6 H's on the product side. So when the mass is different, so in all of the examples that we've just done, the mass has been the same on the reactant side and the product side, which means the equation is a balanced equation. What about when it's a little bit different, when it might not seem balanced? So it can sometimes appear that matter is created or destroyed, but what's really happening is this. Number 1, gas can escape if a container that the experiment is occurring in isn't closed completely. If it's not a completely sealed container, then different gases in that chemical reaction can actually escape. And it can appear that matter is destroyed because the mass might be lower if gas escapes. However, it's not actually destroyed, it just moves to a different location. And because it's not in the container that you're measuring, you can't measure it because it's somewhere else out in the air. And the other thing that can happen that's the opposite, so gases escaping mean that your mass is going to be lower. But another thing that can happen is solids can actually form from a reaction. And when a solid forms, that's going to make the mass actually increase. This is called a precipitate. And an example of a precipitate that you probably can visualize is when you make rock candy. Because you make rock candy from sugar water, the water evaporates and the sugar sticks to the string. So crystals forming are a solid. They are not the same form as sugar water. So that the crystals that form are called the precipitates and will have a slightly higher mass than the sugar water itself. But none of these is actually creating atoms from nothing.